In the annals of our history, few losses sting as profoundly as the destruction of the Great Library of Alexandria. A beacon of human intellect, its very name conjures images of countless scrolls, housing the accumulated wisdom of antiquity. Its demise, a slow, agonizing process punctuated by catastrophic fires and neglect, snuffed out untold discoveries, leaving a void in the historical record that echoes even today. We ponder the what if this unparalleled repository had endured, its light never dimmed. Imagine a different turn, a pivotal choice. Instead of destruction, Emperor Theodosius I, witnessing the precarious state of the library's immense collection in 391 CE, commissions an unprecedented protection effort. Scholars like Theon and his daughter Hypatia, revered for their intellect, lead a massive project. They don't just protect, they meticulously copy, translate, and innovate new methods of archival preservation. This wasn't merely saving books, it was safeguarding humanity's future, ensuring every scroll was a seed, not ash. By the early 5th century, the preserved works of Archimedes and Euclid, no longer fragmented, become fertile ground. A brilliant Alexandrian scholar, Galen, building on Heron's mechanics and Apollonius' conic sections, formalizes a nascent calculus. Imagine, before the fall of the Western Roman Empire, a system for describing change and motion with unparalleled precision. This wasn't just abstract mathematics, it was the key to unlocking advanced engineering, astronomy, and physics centuries ahead of our own timeline. With Galen's calculus, the observational data painstakingly collected by generations of Alexandrian astronomers, Eratosthenes, Hipparchus, Ptolemy, could finally be fully leveraged. By 550 CE, a complete, highly accurate geocentric model of the solar system, featuring precise planetary ephemerides, was standard curriculum. Within another century, a radical heliocentric theory, first proposed by Aristarchus, was mathematically proven and widely accepted, completely altering humanity's perception of its place in the cosmos. Navigation became an exact science, not an art. The theoretical breakthroughs quickly translated into tangible technology. Heron of Alexandria's Aeolipile, once a novelty, became the blueprint for serious engineering. By 680 CE, Alexandrian workshops, fueled by refined metallurgy, were producing rudimentary steam engines. These weren't for toys, they were driving pumps in mines, lifting heavy stones for monumental construction, and even powering early, clunky barges along the Nile. The hum of the first true machines began to replace the clang of hammers, hinting at a new era. The library also preserved texts from Hippocrates, Galen, and countless anonymous physicians. With a deeper understanding of chemistry and mechanics, 7th-century Alexandrian doctors, like the pioneering physician Ilara, began to challenge ancient superstitions. Ilara's meticulous observations and experiments led her to propose a rudimentary germ theory, developing advanced antiseptics from plant extracts and mineral compounds. Complex surgeries, previously unthinkable, became safer, drastically increasing life expectancy in the rapidly urbanizing Alexandrian sphere. The marriage of steam power and advanced mechanics birthed the first true factories. By 750 CE, vast textile mills, using automated looms designed by engineers from Alexandria's Mechanicum Guild, were producing cloth at unprecedented speeds. Grain was milled, metals were forged, and ceramics were produced on an industrial scale. This early industrial revolution transformed labor, creating new classes of skilled mechanics and engineers, while challenging traditional social structures in ways never before seen. With precise navigation and increasingly efficient steam-powered vessels, the Mediterranean became a highway, not a barrier. By 820 CE, Alexandrian galleons, now equipped with rudimentary paddle wheels, were venturing further, establishing trade routes to India, China, and even charting the African coast with remarkable accuracy. Cartography, aided by more powerful telescopes and precise chronometers, became incredibly detailed, mapping a world far larger and more interconnected than our own timeline's 9th century could ever conceive. The need to coordinate this vast network of trade and empire spurred innovation in communication. Building on earlier hydraulic telegraphs, the 9th century saw the development of optical telegraphy, using sophisticated lens systems and coded signals, allowing messages to travel hundreds of miles in minutes. By 950 CE, rudimentary electrical telegraphy, utilizing voltaic piles and refined conductors, began to connect major Alexandrian-influenced cities, shrinking the world and enabling rapid responses to political and economic shifts. The meticulous copying efforts of the early library protectors, combined with advanced metallurgy and mechanics, naturally led to a revolutionary leap. By 1000 CE, the Spolegraphia, a mechanized printing press, was invented in Alexandria, not by Gutenberg, but by a collective of engineers and scribes. This invention democratized knowledge, spreading scientific texts, philosophical treatises, and news across the rapidly expanding Alexandrian influence sphere, further accelerating the pace of innovation and literacy beyond anything our world experienced. The complex calculations required for advanced astronomy, engineering, and logistics spurred the development of mechanical calculators. Building on Antikythera-like mechanisms and Kaelin's calculus, by 1150 CE, sophisticated analog computers were commonplace in major scientific and governmental institutions. These calculators of Archimedes, as they were known, could solve complex equations, predict celestial movements, and aid in the design of increasingly intricate machines. Data processing, in a mechanical form, became a cornerstone of this advanced society. With refined mechanics, lighter materials, and an understanding of aerodynamics derived from ancient observations, humanity finally took to the skies. By 1280 CE, hot air balloons, inspired by principles from Heron's pneumatics and refined by centuries of material science, were being used for observation and short-distance travel. Just decades later, powered gliders, utilizing small, efficient steam engines and complex wing designs, achieved sustained, controlled flight, transforming warfare, exploration, and the very concept of travel. The sky was no longer a limit. The drive to reach the heavens, a dream since antiquity, gained new momentum with the advent of advanced chemistry and metallurgy. By 1350 CE, Alexandrian engineers, inspired by fireworks and the principles of reaction propulsion, were experimenting with solid-fuel rockets. These early designs, while primitive, could launch instruments to impressive altitudes, gathering atmospheric data. The concept of space travel, once a mythical journey, began to solidify into a tangible engineering challenge, pushing the boundaries of human ambition. The crescendo of centuries of accelerated knowledge culminated in an astonishing feat by 1480 CE. Just as our own timeline was entering the Renaissance, this alternate Alexandria launched its first crewed suborbital vehicle. A decade later, the Alexandrian Starship, a towering, multi-stage rocket, propelled its crew into orbit, circling the Earth multiple times before a controlled return. Humanity had reached space, not in the 20th century, but before the Middle Ages had truly ended, forever altering our species' trajectory. What does this world look like? By 1500 CE, vast, sprawling metropolises hum with automated transport and advanced infrastructure. Global communication networks link continents instantly. Disease is largely conquered. The concept of empire shifts from territorial conquest to technological dominance and intellectual exchange. This isn't just an advanced ancient world, it's a radically different human civilization, one that never experienced the Dark Ages, its trajectory defined by continuous, exponential growth of knowledge. But such rapid advancement isn't without its shadows. The societal shifts were immense and often tumultuous. The gap between the technologically advanced Alexandrian sphere and less developed regions widened dramatically, leading to new forms of political tension and resource competition. The rapid pace of discovery also brought philosophical challenges, questioning traditional beliefs in the face of scientific revelation. This timeline, while glorious in its achievements, still wrestled with the fundamental complexities of human nature. Yet, the overarching narrative is one of unparalleled progress. Before our own timeline even saw Galileo turn his telescope skyward, this alternate humanity was already planning lunar missions and terraforming distant planets. The Library of Alexandria, in this vision, became not just a repository, but a launchpad, a testament to the idea that knowledge, meticulously preserved and continuously built upon, holds the very key to unlocking humanity's wildest dreams, truly catapulting us beyond earthly constraints and into the vast unknown.